Next, we have a tech talk entitled An Automated Cloud Lab in Action, presented by Dr. DJ Kleinbaum, co-founder of Emerald Cloud Labs.
Thank you, everyone. It's great to be here. I do recognize that I am now the only thing standing in between you and lunch, so I will try very hard to be interesting and, failing that, brief. What I'm going to do today is to show you what it's like to use and drive science through a cloud lab. But before I get to the showing, first I need to do a little bit of telling. Specifically, what is a cloud lab? So a cloud lab is a remote control scientific laboratory. When we designed this, back almost 15 years ago at this point, we were very inspired by TSMC specifically and the foundry model in general, where you are centralizing a physical infrastructure and resource and the execution of the work, and then distributing the design and analysis of that work. Said another way, a cloud lab is dumb muscle. Our job is to faithfully execute the experiments that our users and scientists design, and then to ensure that all the instruments that are done that execute that science are operating nominally in a centralized cloud lab facility when we do so. So you've got all this dumb muscle. What do you do with it? There are three ways that we have seen people driving research forward with a cloud lab. The first one is just open-ended research, where scientists use this as a daily driver to design, execute, and analyze their data. So they'll enqueue a bunch of experiments, they run in one of our centralized facilities, and then the next day they're analyzing that data and designing a new set of experiments. Up a level of automation from that is high-throughput experimentation, and this is very analogous to what companies like Recursion are doing internally, where you are using work cells to drive very large numbers of very similar experiments through a pipeline of assays. And then the third, and I think the reason why I'm here, is this idea of self-driving labs, where because what we've built is effectively an application programming interface to an entire laboratory, you're able to build closed loops between AI and ML systems and the lab. So the AI designs the experiments, enqueues them in the cloud lab runs them, and then all of the data and metadata goes back into that AI, which uses it to design the next set of experiments. So in this way, you're able to turn the cycle of research much faster by just giving an objective in terms of what you want your research to accomplish, and then letting the system go to work on it. There are a number of different ways that we've seen people take advantage of this so far. One of the more interesting ones is that it's not all directly related to the research. Because you truly have a computational interface to an entire laboratory, we've seen people plug in not just around designing experiments and analyzing results, but also doing things like optimizing reagent usage. So there are many different avenues of value that you can unlock when you have a full computational view of everything that happens in a laboratory. But that's plenty of telling for now. So let me show you what it actually looks like when scientists drive experiments in a cloud lab. So the first thing that I'll say is that this was all designed so that a human scientist could sit in front of it and point and click their way to designing an experiment. So as this is happening, as you're selecting the experiment you want to do, as you're choosing your input samples, everything can be done on the left here in this point and click interface. But on the right, what you'll see happening is the actual code being written by the system that will tell the software that drives the lab exactly how you want your experiment run. And it's important to point out that there are hundreds, sometimes thousands of experimental parameters that we need to give scientists access to in order to allow them to run the experiment exactly as they would as if they were standing in the lab themselves. And so our system, once you give us your samples and tell us what type of experiment you want to run, it will take its best guess at what all of those parameters need to be, but you have the ability to reach in and change any one of them, and in that way sort of talk back and forth with the system behind the scenes that is figuring out what all those parameters need to be. And that can include things like, not just what is the volume that you're injecting and what column are you using, but how are you collecting samples? Are you going to do automated analysis of the data that's going to come out of it to feed into another experiment? We've had to build a system that is fully flexible and allows scientists to make any arbitrary decision about their experiment that they could if they were literally doing it themselves by hand. Once you've designed that experiment, it goes through a set of validation checks. So we have to check hundreds, sometimes thousands of parameters to make sure your experiment can be faithfully executed in the lab. But then once it is, it enters an execution queue in our laboratory and usually starts within 5 to 10 hours. Then as soon as the experiment is completed, all of the data is handed back to the scientist through the same software application, which also includes a whole suite of tools for analysis, visualization, plotting, really figuring out what happened in your experiment and deciding what you want to do next. The last point that I want to leave you with is that thus far, all of this work has been done, almost all the work that is being done in the Cloud Lab today is being done at large pharmaceutical companies, and specifically the later stage work at these pharmaceutical companies. So product development, CMC, quality testing. To be candid, it's all things where what they care about is that the results they get back are better, faster, and cheaper than what they were doing before. To my mind, it's not actually taking advantage of all of the value that you can drive by having this full computational interface to the lab. That's one of the reasons why I'm so excited to be here today, because the ability to tie the world of atoms in terms of the physical lab to the world of bits and everything that is happening in AI, I think is where you're going to see a lot of innovation, not just in pharmaceuticals and materials, but also in agriculture, in diagnostics. There's so much value to be unlocked there, and we are very much still in the early innings of all of this. Thank you.